Hi, I'm Douglas Smith, and this is Layout Analysis Error Prediction Improvements. Layout analysis is a visual method of interface design that organizes interface elements into functional groups. The interface elements are then rearranged according to importance, sequence of use, and frequency of use within the functional groups. Layout analysis is quick and easy to apply, but it has a few disadvantages. Among these are low reliability and validity, and lack of consideration for task performance time, cognitive analysis, and human error. The method described in this presentation is focused on error. To keep things simple, we approach both error and UI design from a high level, reducing considerations to just three each: temporal, spatial, and cognitive related errors, and interface layout density, uniformity, and overload, where overload is the property of assigning multiple functions to one design element. The tool chosen for this method is a logistic function, used to analyze a wide range of natural and artificial processes. Modifying it for these purposes gives the layout error analysis function, or LEAF, as seen to the right. The variables k, x, and f of x will be discussed next. This table shows the intersection of error types and design considerations and the associated design coefficients. The design coefficient k rates the impact of a given error type and the likelihood that a particular design consideration will cause that error. Design coefficients are set by the designer based on the type and purpose of the UI, irrespective of its layout. These coefficients do not change once selected. Quality and error ratings can also be assessed with a similar matrix. Here are the general scales for all variables. The quality X or Q rating grades a particular layout with respect to error types and design considerations. The error rating F of X or E rating is the output of the LEAF. Its scale serves to make sense of the numerical output and identifies general UI issues to the designer. The process to apply the LEAF is as follows. Step 1. Assign the design coefficients. Step 2. Determine quality ratings. Step 3. Calculate error ratings. Step 4. Average error ratings either row-wise, column-wise, or altogether. Step 5. Repeat for further iterations of the interface layout and compare the results. Using Excel or a similar program will make it much faster. This is an example of outputs from the LEAF using an initial UI design and a revised version developed with layout analysis. As you can see, it is possible to numerically identify a subjectively better design with the LEAF. For closer designs, it could also help identify differences that are not immediately apparent. In closing, the LEAF is a quick and easy application of the logistic function to layout analysis, which aims to numerically capture some subjective considerations of error in a given UI. In order to increase the LEAF's usefulness, a more robust mapping of design and error to the simplified categories listed in this method is needed. Further testing to determine the validity of the coefficients should also be done. The LEAF, however, is a good starting point for numerical assessment of layout analysis error prediction. This has been Layout Analysis Error Prediction Improvements with Douglas Smith. Thank you for your time.